Good day, everyone. Today, we delve into the captivating relationship between interconnection and impact of science and technology on society, with a specific focus on historical and contemporary analysis in the Philippines. Join us on this journey as we unravel the intricate interconnection and profound impact of these forces on Filipino society throughout time. This analysis will delve into the intricate relationship between science and technology and their profound influence on society, particularly within the context of the Philippines. We will examine the historical evolution of this relationship, tracing major advancements and their societal impacts. By exploring both historical and contemporary perspectives, we aim to understand the ongoing interplay between scientific progress and societal development in the Philippines. These are the list of contents. Number 1, objectives. Number 2, brief history. Number 3, timeline. Number 4, major historical advancement. Number 5, major modern advancement. Number 6, societal impact. And lastly, number 7, contribution and challenges in the Philippines. Our objective is collaboratively present research findings and engage with peers on the topic to examine the historical evolution of technology and its social impacts, to understand the interrelationship between scientific advancement and societal.
Brief history of the world since 1500. The scientific revolution spanning from the late 15th century to the 18th century represent a pivotal era in the history of science, characterized by profound changes in thought and methodology. This profound saw the transition from medieval scholasticism to a new approach grounded in observation and experimentation. Key figures such as Nicholas Copernicus, who proposed a heliocentric model of the universe, and Galileo Galilei, who championed the use of the telescope, challenged long held beliefs and laid the groundwork for modern physics and astronomy. In addition to astronomy, advancements in mathematics, exemplified by the work of Isaac Newton, who formulated the law of motion and universal gravitation, further revolutionized scientific thought. The study of biology also progressed, with figures like Andreas Vesalius making significant contribution to human autonomy. Chemistry evolved as well, with Robert Boyle's emphasis on empirical methods. Overall, the scientific revolution not only transformed scientific inquiry but also reshaped societal views about nature, leading to the Enlightenment and the eventual rise of modern science. This era exemplifies the power of human curiosity and the relentless pursuit of knowledge, fundamental alternating humanity's relationship with the natural world. Timeline: prehistoric to c. 3000 BCE. During the timeline from prehistoric times to 3000 BCE marks a significant evolution in the use of tools among early hominids. Initially, animals, including our ancestors, utilized natural objects like sticks and stones for various purposes, demonstrating an innate ability to manipulate their environment. Over time, this rudimentary tool use evolved into deliberate crafting of tools, which laid the foundation for human innovation and societal development, ultimately leading to the complex civilizations that emerged around 3000 BCE. Urban Revolution. The urban revolution signified a monumental shift in human civilization, as it heralded the inception of urban life and the complexities that accompany it. During this period, the establishment of cities necessitated innovation in agriculture, trade, and governance, leading to the development of new tools and techniques. This era not only fostered a surge in population density but also catalyzed social stratification and cultural exchange, laying the groundwork for future civilization. The interplay between increased resource demands and technological progress fundamentally reshape human interaction and societal structures. Medieval advance. The Middle Ages, often characterized by the term Dark Ages, represent a complex and transformative era in European history. While it is frequently viewed as a period of stagnation, it also laid the groundwork for significant advancement in various fields, including agriculture, architecture, and philosophy. The emergence of feudalism and the establishment of universities during these times reflect a society in transition, grappling with the remains of Roman civilization while forging new paths. Thus, rather than merely a time of decline, the Middle Ages can be seen as a crucial phase of development that ultimately set the stage for the Renaissance and the modern world. Scientific Revolution. The scientific revolution emerging during the Renaissance fundamentally altered humanity's understanding of the natural world, fostering a spirit of inquiry and empirical investigation. This period was characterized by the rise of nation states, which facilitated the funding and support of scientific endeavors, while the Protestant of Reformation encouraged a questioning of traditional authority, including that for the Church. Furthermore, overseas expansion by European states not only spread new ideas but also introduced novel technologies, thereby creating a dynamic interplay that propelled both scientific and societal advancement. The prehistoric period, a journey through early technological innovation. The prehistoric period marks a pivotal era in human history, characterized by remarkable technological innovations that laid the foundation for future civilizations. Early humans developed essential tools from stone, wood, and bone, which facilitated hunting, gathering, and the processing of food. The invention of fire not only provided a warmth and protection, but also revolutionized cooking methods, enhancing nutritional intake. Furthermore, the creation of rudimentary art and symbolic communication reflects the cognitive evolution of early societies, showcasing their ability to express complex and ideas and emotions.
Prehistoric period. The prehistoric period marks the earliest phase of human history, defined simple tools and the absence of written records. During this time, humans relied on natural resources and slowly began to shape tools from materials like stone, wood, and bone to improve their survival. This period encompasses the vast expanse of time before written records, spanning millennia of human history. This era witnessed the emergence of early humans, the development of stone tools, the domestication of animals, and the rise of agriculture, shaping the foundation of human civilization. Stone Age technology. The Stone Age saw the development of rudimentary tools, marking the transition from using natural objects to shaping them for specific uses. These tools, ranging from simple hand axes to more complex spear points. Early humans learned to shape stones for tasks like hunting and building, laying the foundation for later advancement.
Tool-making evolution. Initially, humans used unshaped stones as tools, but over millennia, they developed the skill to craft specialized tools like choppers, scrapers, and hand axes. These were used for hunting, gathering, and other daily activities. In my research, the earliest stone tool making developed by at least 2.6 million years ago. The early Stone Age began with the most basic stone implements made by early humans. Specialization and advancement. By the Neanderthal era, around 70,000, tool making had become more specialized. Later, Cro-Magnons developed advanced tools like spears, harpoons, and the first composite tools made by combining a head with a shaft.
Modern Advancement Telescope. The telescope, invented around 1608, revolutionized our understanding of the universe. Initially used for astronomy, it enabled groundbreaking discoveries such as Galileo's observation of Jupiter's moons and the phases of Venus. This expanded our knowledge of celestial bodies, challenging geocentric views and paving the way for the heliocentric model. Societal impact in the prehistoric period. Improved survival rates. Advanced tools allowed early humans to hunt more effectively and gather food, leading to better nutrition and higher survival rates. Establishment of settlements. The ability to acquire food reliably contributed to the formation of semi-permanent settlements, reducing the need for nomadic lifestyle.
Development of social structures. As the communities formed, social hierarchies began to emerge, leading to organized groups and division of labor based on skills and abilities. Enhanced communication and collaboration. Tool-making required cooperation and shared knowledge, fostering communication and social bonds within groups. Social impacts of telescope. 1. Shift in worldview. The telescope contributed to a paradigm shift in humanity's place in the world or universe, promoting a scientific outlook over superstition. Number 2. Technological innovation. Developments in optics and imaging technology have spurred advancements in various fields, including medicine and telecommunications. Number 3. Inspirations of exploration. The quest for knowledge about the universe has inspired generations of scientists, leading to increased interest in STEM fields. Contributions and challenges in the Philippines during the prehistoric period. The Philippines, like many regions, experienced its own unique set of technological developments and challenges. During its prehistoric period, archaeological evidence shows that early inhabitants of the archipelago engaged in tool-making, food gathering, and adapting to their environment in ways that mirrored broader prehistoric trends, but were also shaped by the island's specific geography and climate. Contributions. Tabon Caves and Early Tool Use. The discovery of the Tabon Man in Palawan, believed to be around 16,500 years old, provides insight into early human activity in the Philippines. Stone tools found at the site show that early Filipinos engaged in basic tool making, using stones for cutting, hunting, and processing food. Shell tools and maritime culture. Due to the Philippines' island environment, the use of shell tools became a significant development. Early inhabitants created tools from shells which were abundant along coastal areas. These tools were used for fishing, gathering food, and building shelters, marking a key adaptation to their maritime setting.
These are the challenges in the Philippines during the prehistoric period. Geographical fragmentation. The archipelagic nature of the Philippines made the diffusion of technology across different islands more difficult. Communities in various islands often develop in isolation, leading to slower technological exchange compared to continental region. The archipelagic nature of the Philippines created physical barriers that slowed down technological exchange between islands, leading to uneven development and isolated innovation in some areas. Natural disasters. Being located along the Pacific Ring of Fire, early Filipino communities faced constant challenges from natural disasters such as volcanic eruptions, earthquakes, and typhoons. These events periodically disrupted human settlement and necessitated adaptive strategies for survival. Early Filipino communities situated along the Pacific Ring of Fire frequently encountered natural disasters like volcanic eruptions, earthquakes, and typhoons. These events often disrupted settlements, forcing the people to develop strategies for survival and adaptations. Limited resources in some areas. While coastal regions had an abundance of shells and marine resources, some inland areas had more limited access to essential materials like good quality stone for tool making. This created a reliance on trade and resource management in these areas. Coastal region had plenty of shells and marine resources, but some inland areas struggled with limited access to essential materials such as high-quality stone for tools, and as a result, these inland communities depended on trade and careful resource management. Contribution and challenges in the Philippines of telescope. The Philippines have made significant contribution to astronomy through various initiatives and the establishment of observatories, but it also faces challenges related to the field. Here's an overview of contributions, challenges, and notable events involving telescopes in the Philippines.
Contributions: Philippine Institute of Volcanology and Seismology. Fieldbooks. This institute uses telescope for monitoring celestial events and understanding potential impact on Earth. The Manila Observatory. Established in 1865, it is one of the oldest observatory in Southeast Asia, focusing on atmospheric science in astronomy. National Astronomical Research Institute of Thailand, NARIT. The Philippines collaborates with this institute to advance astronomical research and education.
Challenges: limited funding. Many astronomical projects face budget constraints, hindering research and the purchase of modern equipment. Next, light pollution. Urbanization, particularly in Metro Manila, contributes to light pollution, making it difficult to conduct astronomical observation. Last, technological gaps. The country often lacks access to the latest telescopes and technology, limiting the scope of research and observation.